Alex here from Blacksheep IT Consulting. So today we are going to look at a dashboard, and the dashboard looks like so. Okay, there it is. That's what we are going to create over the next few, 1 or 2 hours. I'm planning on a video series on that. That's a dashboard, all right. So it shows opportunity data, quote data, the number of orders, number of contacts, number of service requests for the selected customer. And just to put in another example how to use that, the current news. So that dashboard you can open up for any account that you select. You can see it's a button on the form applet. So let's do it again. There's no data for opportunities or quotes that's shown here for this customer. Okay, so now we have seen what we want to create. Now let's dive in. What are the ingredients of that solution? And do keep in mind that this is a completely educational prototype, so don't use this in mission critical environments. It's something I put together to demonstrate various use cases of Siebel CRM, the REST API, and of course OpenUI. So let's start with the application running in the browser. So that's what we know about Siebel OpenUI. There is a /app URL, an application endpoint, and of course it's sending requests to the AI, which in turn are sent to the application object manager, which in turn queries the database or generates statements against the database and so forth. So that's the basic Siebel architecture. No need to waste more time. And so now if we want to show additional data that is not on the view right now, we have to fetch it literally. So when the dashboard pops open, we must grab all this opportunity data, quote, orders, and whatnot. And that, in the solution, we use the REST API. So fetch or XML HTTP requests or whatever asynchronously are sent. So all requests that are needed are sent immediately. Let's say 5 separate requests to the AI. That, of course, will spawn sessions, multiple sessions in parallel on the AI object manager, so fetching the data in parallel, and when the data is returned, of course, updating the dashboard. So we'll see that, of course, there's a wait time, but we want to populate the screen as quickly as possible. So whatever we get first, we update on the screen, and when we take something longer to get something, we will show an icon that tells the user they have to wait a little bit. Now let's rehearse a little bit the available resources for the Siebel Inbound REST API. So this is of course covered in great detail in the REST module of the Siebel 23 Plus workshop. Check out the link in the description. And we can of course call the data API. So we can call the data API /data, that would be. And that would mean we would need either a standard integration object, and that would use AI Siebel adapter for the query internally. So let's see if we need certain fields. Of course, we can specify them in the REST call. That would be an option, but I refrain from that because, well, first and foremost, I want to show off the other ways to call the REST API. And this would require, let's imagine, creating a new field, a custom field in a business component. You would have to extend the integration object as well. So there's repository work to do. What we want to achieve is fetch any field of any given business component at any time without additional repository work. So as a matter of fact, the solution uses a custom business service. So we use the service API. So there's only one-time repository work, and we can call that business service once it's registered from, well, the JavaScript in our browser. There would be an option, of course, to wrap all this in a workflow and call that workflow. Why not? Workflow is just, well, another way to carry out the business service, really. So these three options you really have when you want to do what we achieve here in the solution, get additional data from different business objects, business component combinations, different queries you need to run at any given time. So we decide, for the sake of the prototype, that we write a custom business service. Now here, the ice is getting very, very thin here. And for good reasons, I do not provide the code as a solution file, because you will just copy it into your environment and it will do you no good. This is prototype code. So our business service, the main function here is get data. And that get data function receives an input property set apparently. And let's point out the most important stuff here. There's a search expression, maybe a sort spec, and the business object and business component and view mode will be given, and it will establish that business object, instantiate it, and will instantiate the business component as well later on. So here we default a little bit. We have a field list as well. The field list is a property set, a child, with just the field names, literally. So no values for the properties, just the field names in the names of the property. There's a default view mode, there's a default field list if there's none, and we always set the ID field if it's not given to, because we always want to return the row ID of the record. So the business service can handle parent context, but let's not spend too much time on that. And here's the main query. So we instantiate the business component, set the view mode, activate multiple fields because it's a property field is a property set with the field names, so that works pretty well in one line, and clear the query. And if we have a row ID, we use that to search, and if we have a search expression, no row ID, then we use the search expression. So for more variable queries, of course, flexible. Sort spec will be set as well, and then we do a forward only regular query check for first record. So that's mainly a generic business service that can query any business object, any business component on any view mode. And you see immediately how dangerous this is. So this is why the code is not provided as is, because it's way too dangerous to put into production. Everybody with access to that business service could query anything with the full view mode. So you have to restrict that very thoroughly, restrict it to only a few business objects, business component combinations, restrict it for users. So for example, you cannot use this as sadmin. All these restrictions must be added to the code. Do your security homework, basically. So acknowledging that this is insecure prototype demonstration code, we now can loop the record set, and we create a new property set called row data. And then I always wanted to try this, get multiple field values. So we have that property set with the field names and the empty property set, and get multiple field values really populates that row data property set with the field values of the given current record in the cursor. So that's really nice. Then we set the type, set the value to an iterator, so we have like a sort order of sorts. And we also set the ID for good measure. That's probably redundant here. And then we have one row, and we add it as a child to the object data, the container properties set, and we do this while we have a next record. So it's a simple do while loop. If there's no record, we throw a bunch of exception, which we catch and put in the output property set. Finally, we work with the output property set and add some output that might be useful, especially, of course, the object data as a child. That's the result of the query. And then we nullify all kinds of stuff, just keeping things safe in memory terms here, because this will run quite often. Okay, so you get the general idea. You could use the data API then you would more work with integration objects, or you could create a workflow process that queries, or you can write an eScript business service like I did. So I opted for this one because it's generic. I can use it for anything. Again, as a reminder, this code is very dangerous. It's not secure. You should not use code like this in any Siebel environment, except if you're goofing around and prototyping like we do here. So take this with the caution that's necessary as a Siebel professional. All right, so that's the service. Now let's go to the business service access view. And this is the next step. Once you have tested and delivered your business service, you must make it available through the REST API. So that's a little bit of REST API work here. You go to that business service access view, you create a record for the business service, add any responsibilities, and those responsibilities will have exclusive access to any of the listed methods of the business service. Exclusive means nobody else has. That's important. So again, don't put workflow process manager in here, or EI Siebel adapter, or whatever general business service. You get in trouble. So once this is possible, so once this is done, we have to take care about how this REST API will be invoked. It will be JavaScript in a running Siebel Open UI session. So inside the Siebel application, there will be a fetch call in JavaScript. How to authenticate that call? That's basically the question. So let's go to SMC, Siebel Management Console. Let's take a look at the application interface profile that I'm using here on this machine. So in the authentication section, you have the REST inbound authentication. This is how inbound REST calls are authenticated. We could do anonymous, but guest CSD is likely not seeing any data, and it shouldn't, so that's good. So anonymous is out of the question. Basic auth would require that we know the password of the user, which is, well, possible within a session, but it's difficult. So, or the user would have to enter it again, annoying the user. So for the sake of demo, I enabled single sign-on for REST inbound authentication. That allows me to enter a trust token, which we will see in a moment. You have to repeat that exact token in the security adapter, and a user specification. This is an arbitrary text, and it's really the name. Well, what does the explanation say? When SSO is configured, provide the user spec where the application interface REST channel looks for a user's username within the source given. Well, that's a little bit ambiguous. Basically, this means this is the name of a header parameter in the incoming HTTP request. So you need to populate this header I named Siebel REST user. And the value of that header is a valid Siebel user name, like ccheng or sadmin. And the security adapter will then only get this name and will re-authenticate against the security adapter's, well, data source. That could be LDAP, Active Directory, or the database. So we must have an SSO-enabled security adapter to go with that, to use for the object manager. Okay, so that's a little bit of sideway discussion. It's not related really to the dashboarding and all that stuff we are going to work on, but it's an interesting way of allowing REST calls from within a user session, because the username we have, and simply pass the username as a header and get SSO into the REST API. But keep in mind that this is then the only setting you can have for all incoming REST calls on that AI. So you might need a secondary AI just for that purpose. And keep in mind that when you set single sign-on, you must also use the migration application must also use single sign-on. Okay, let's check out the object manager, which of course is the EI object manager. We're not expecting anything different. Let's check out the configuration of that object manager. So here in the component definitions, query for the EI object manager. There it is. Let's check out the parameters. And let's find the security parameters. So there's the security adapter mode, which, as you can see, the default value being database. I change it to DBSSO. So now this is supported since, can't remember really, 20 dot something, when Oracle added support for SSO for database security adapters. So I've created a special database security adapter I call database security ADBT SSO. Notes the default is the standard database security adapter. So that security adapter, of course, is now really interesting. So let's check out this profile. It's the alias of a profile. Which is of the infra security adapter database subsystem type. So you can basically copy the regular database security adapter, copy that, and make changes. So the parameters on this one are, well, obviously data source to point to the Siebel database, as you don't have to change that. And in advanced, actually you have a shared database username. So don't be confused, I use LDAP user because that exists in my Siebel database, and the password is specified here. So it's going to authenticate against the database to check the user using this user. It is enabled for single sign-on and the trust token. You can't see the value here, but that's the trust token I had in the AI profile is repeated here. So that's basically when the trust token matches, it knows it comes from a trusted source, comes from the AI. So it will use this information to look up the user in the database, does it exist, and is it a valid Siebel user? And then it will open the session immediately without prompting for a password. Okay, so that's another side note on this dashboard example that we have. If you want to enable REST calls with SSO, that's one way of doing it. Of course, you can use another SSO enabled or even OAuth enabled inbound REST API. So you could use your LDAP or Active Directory. I'm using the database SSO because I just have a database here and it's cool to use and see in action. So now let's test the REST API. So I have prepared a post request for the service API, the name of the business service, BCRM dashboard service, the name of the method. Now in authorization, I will set no auth. Remember that header I would have to set. And let's use a user. I know it exists on the database. So that's, again, remember that's the user specification on the AI profile. It's now a header in my post request, and the value is a valid Siebel username, dev1 in my case. So we need a body. That's not the correct body. Let's use match request format. Another neat little trick you can do in higher Siebel versions, so you don't have to worry about that body in the body. So without match request format, you would have to start like this with a body, but now we we don't. So we want to run a query, and I can remember, let's say business component is one thing you have to specify. Let's use account. Then we have a business object. Let's take account as well. And then we have a search expression. And let's say that's any name like M asterisk. So anything that starts with an M probably need a view mode, but let's set it to 0. That's like my view or sales rep. So it takes the integer representations, well, or a string actually, numbers, the constants. So let's see if that works. And well, yes, so there is something coming back. 82 records with a value. That's the value of the output property sets. 1, 2, 3. They're okay in the same order as they come back from the sort spec, so you can reorder it if necessary. And that's just the ID because we didn't specify the field list. Now the field list is a child property set, which you do in REST like just a child object, and you specify the fields you want, like name, sorry, keep typing commas, and location. So I know these are two field names in the account BC. Okay, and it returns the data, and actually quite fast, 100 milliseconds, not too shabby, for whopping 82 records that match the query. And indeed, it's starting with M, and we have the location. So we can exactly specify what we want back and what's the query specification. A very high degree of flexibility here. Again, I choose this because it's more flexible than the data API, because data API, any new field I add to a business component, I have to extend an integration component and deliver it. Let's experiment with view mode. 3 is like the all across organizations, I guess, and that's now 200. Okay, how large can the data set be is probably limited by the 10,000 rule. I noticed that it goes over 10,000 really, so for very large queries this response can become quite large. So of course you only want to query within an account as child records. So, and also one limitation of this, it doesn't do child records, it's just query this business component on this business object with the option of establishing a parent context if you wanted to. So that's all it can do. So it's not truly a hierarchical response. If you want that, you have to go with integration objects. It's probably the best idea. And then you get all the hierarchy you want. All right, so that's the first test. The post requests are working fine. We get some data back as well designed. So the next step is to put this into JavaScript. Postman has this truly hidden away super feature code, the code button. And yeah, I always use this, to be honest. I'm too lazy. That's my JavaScript fetch syntax. And so it puts this all in one JavaScript, well, snippet. And of course, that's a super starting point for any function you write where you wrap this fetch into. And fetch inherently is asynchronous. It's an async call, so it will wait and then process the response and get the text of the response, and that's another asynchronous call, and then it will have the results as text, and then you can, well, log it out as in this example, or do anything other useful things. And there's a catch as well. Exception handling is built into this example. So the asynchronicity is very good for us because that's exactly what we want. If you want synchronous calls, you probably have to go with jQuery and set the type to synchronous or something, or asynchronous false. It's possible. But fetch is what we want. So let's copy that code and let's just quickly run it. So go to the developer tools console. Let me just reload this. So simply paste the code in here. I would run the exact same query from a browser. So you saw, for a short while, you saw promise pending. Yeah, you saw that. And then it came after, well, half a second or so, 200 milliseconds. We can see this in the network tab. So let's clear the network tab. Let's just run this again. Now it's faster, of course. It's caching stuff already, but yeah, it took like 193 milliseconds. So there you go. That's your request as your response. Pretty print that. It's the exact response we see in Postman. Perfect. There's the payload. Yeah. Okay. So it's definitely possible to, well, process that return data in JavaScript. So now we have set the stage. We now have a data source. We can do fetch, JavaScript fetch calls to a Siebel Business Service from inside the browser. And we can do this in parallel. So imagine for each of the requests you make, you just fire them off and you will have one EI Object Manager session per request. There's the full load balancing wazoo, and so it will be as fast as possible and parallel as possible. Whenever that result is returned, you will go in here, or we will go in here and process the result. Okay, so the first part of this multi-part series stops here. So let's go back to the diagram we have. So we have basically established the background for using the REST API from JavaScript. So we have a business service, a custom business service that enables us to query any business object, business component combination, very dangerously so, but for the prototype, and returns data that we can then use to populate the nice little dashboard that we have in mind. So see you around for the next module. In the next video, we'll start working on a physical renderer that accomplishes the task of actually pulling together all this data and visualizing it on a dashboard. Thanks for watching. Take care and bye-bye.